Finally, our last model of the entire class, right? So other than the fact that this model will involve the use of non-smooth functions, there's no specific reason to choose this particular example as our last. We could have used any of the problems involving the use of the if, sum if, VLOOKUP, index, min, max, absolute, and whatever, any of these commonly used Excel functions in many spreadsheet models. So we'll open the elect 6 underscore non-smooth Excel file and review the data on 15 cities here on the left side, the number of registered Republican and Democratic voters in thousands, right? So city 1 has 80,000, city 2 34,000 Democrats, 80,000 Republicans, and so forth. We need to assign each city to one of the 8 congressional districts, okay, and add up all the Republican and Democratic voters or votes, right, under a particular specific assignment. Then, taking the perspective of one of the parties, we want to determine whether the party is projected to win or lose a particular district in this last column, and add up the winnings at the bottom to maximize, and maximize them by changing the assignments of cities to congressional districts. The only requirement that's going to be there is the relative balance of the total column. The balance of Republican and Democratic votes has to be between 150 and 250,000. Okay, so we'll start by randomly assigning cities to districts because there's 8 districts and 15/16 cities, so that means 2 cities per district. So 1, 1, 2, 2, 3, 3, and so forth. The last one, 8th district gets city number 15 because it's an odd number. Then we need to use the sum if function. Okay, right here. Let me see if I need to zoom in some more. Sum if function. Okay, using the assignment as the range. Okay, the criteria is 1, so this is going to pick up only the first 2 rows of the Republican, voters, right, which is the sum range over here. So it's essentially going to add 80 plus 40, 43, get 123, right? So 123,000. I'm going to fix the blue column D as well as the purple column B and let the criteria flow from 1 to 2 to 3 all the way to 8. Okay, and then if we are careful here, we can also lock up the D column here, and I believe then NF, and then we can actually move this to the right and get the total number of Democrats. 95, 13, 16, 95 sounds right. Pull all this down and then add these guys up to get the total number of voters. You will notice after you do that there are several districts like let's see, number 3 and 5 where the maximum 250,000 is exceeded, and then also there's two right here, the second one and the 8th one where the total number is below 150,000. I believe the others are fine. Now, taking the perspective of, for example, Democratic Party or Democratic base, we can say if the number of Democratic votes projected is greater than the number of Republicans, then 1 represents we won that district, 0 represents we didn't. Okay, and then if you drag that down and then add it up, you'll see that with this sort of random split, the Democrats are projected to win 4 out of 8, roughly 50%, which you would of course expect with a random assignment, right? So now the question is whether there's a way to reassign, these cities to these districts, okay, in a way that from a Democratic perspective I can increase the number of districts 1 to maybe 5 or even 6 while observing the restriction that the total number of voters per district is between 150 and 250,000 voters, right? So it is a relatively easy solver model, again, where we set up the solver to maximize the total number of districts won by Democrats by changing the assignment cells here in orange range. Also, the constraints, the regular ones, are that the total number of voters has to be under 250 and total number of voters has to be at least 150. Okay, in addition to those, obviously the assignments to districts cities to districts have to be integer, right? Have to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, and also it cannot be just any integers, right? We have to add the bounds that this has to be less than 8, right? Because there is no district 9, 10, and 11. It has to be greater than 1. There is no district 0 or -1. None of those make any sense either. Okay, and as it turns out, the evolutionary solver that we'll end up discussing in a minute needs these kinds of bounds to do its thing. Okay, so first thing to notice, right? It's not clear what type of model this is. It has, some of these Excel functions like if and sum if, and if I try to use the nonlinear, you'll see that it simply won't work. You cannot find a feasible solution. It's also not going to work with a linear model. The only one that's going to work with, that's currently available here that we are discussing really, is standard evolutionary model. That does not have any issue with the ifs, sum ifs, VLOOKUPs, max, min, absolute value, or any of the other Excel functions that were discussed so far. So if I use the standard evolutionary model, it should pretty quickly converge. You can see down here to a solution. Although that's not always the case in this simple model. And that number should have been 5, not 3. So yeah, this is not good. Let's see. I just did that. It should have been 5. So I'm going to have to try this again. Without any. Let me try this without any assignment at all and see if that makes a difference. This is sort of an unpredictable nature of these problems. You can get stuck in a suboptimal solution, which or come up with an even better one than I expected. Let me see if it's really true. I had 5. This one 188. These guys all seem to be within the range, right? These guys are all 1 through 8, okay, and the Democrats, according to this, 1, 6. So go figure. We're going to discuss this more in class. I just wanted to switch back to the presentation and I'll make this video way too long. And a few notes on the evolutionary solver here. So the two of the non-smooth functions that we used were if and sum if. To tally up the party votes and if it was, for that, whether the Democrats won or not. The rest of the functionality is pretty standard, okay, including those integer constraints and so forth. None of those are an issue, right? So again, we showed that the nonlinear solver does not work. Evolutionary solver is kind of tricky, because I expected the Democrats to win 5 districts. I got 3, and then I deleted all the assignments and restarted the evolutionary solver, and then I got 6, which I did not expect at all. Okay, and all the while observing those minimum maximum restrictions, right? So we're going to elaborate on this much more than to say that the evolutionary solver is based on generic algorithms that start with an initial population representing a feasible solution and then tries to mutate those, right, in this case those assignments of districts to cities into other feasible solutions, all the while improving the value of the objective. Having those bounds 1 through 8, right, on decision variables is one of the critical components in creating the initial population space. But again, the discussion on details of the evolutionary solver and these genetic algorithms is beyond the scope of this class. Right, now, last slide of the class. Okay, we introduced several of these nonlinear models. All of them were nonlinear programming problem because the demand curves, distance functions, advertising response functions, portfolio variance were all nonlinear in the decision variables, namely price, location, coordinates, number of ads, investment weights, and so forth. For pricing model, the main goal was to find the optimal price and maximize the estimated profit. Location model is aimed to find the optimal location for a warehouse or a service center with the total smallest weighted distance to its customers. With the advertising model, determining the optimal use of advertising budget to maximize the estimated sale was the main objective. For the portfolio model, this one was concerned with determining the optimal set of investment weights that met the expected return at the smallest possible risk. Other nonlinear, namely non-smooth models resulting from the use of if, sum if, VLOOKUP, and so forth, other Excel functions were also introduced. And all of this will be discussed, as usual, more in class and in your last assignment. Okay.